So this is going to be a very short video to demonstrate how to use HECRAS for modeling. I will be using a hypothetical channel supplied with hypothetical input hydrograph to simulate the result. To do this, I expect you all have now installed HECRAS. So if you are not able to install HECRAS, just log into www.google.com and then type in HECRAS. So the search result it will direct you to the link from where you can download the HECRAS program and then install. I have not installed with all the example files, or you can install with some example files if you want to see how people have already done the modeling. It will give you a better idea. So this is going to be a very simple and straightforward tutorial on how to use HECRAS. To do this, let's start with HECRAS. When you launch this program, a very simple window pops up, and if you see it for the first time, you see it as the project is empty, everything is empty. If you have just installed, your unit must be US customer unit. To change this to IS unit SI units, just go and do the units. So you can click on this and it will set your unit to default, and you can also set it as default. Okay, so that was the first thing. So let's start with the program. First, let's create a new project, or you can open a project or you can create a project. So for this is for the first time we're creating it, so let's create a new project. So right now I'm in document folder, so let's create a new folder and name it as HECRAS. So inside HECRAS I'm project 1, so I'm naming my project as project 1. You can name it according to your project. So all right, so it's saying the unit will be set to SI units, but it can be changed later. So I will be using in SI unit, so no matter. So here comes the project is project 1 and its directory is this. I always recommend people to create a new folder because HECRAS tend to generate so many files. Okay, with this, next step is to create the geometry, and to do so you can click this button or you can go to edit and geometric data, and we are going to create a very simple river stretch. To explain you on this, I'll be doing the modeling for this rectangular channel with this as the inflow hydrograph. Hydrograph has been generated from this equation, and let me do it for channel number 10. So we have to create a channel geometry. So for this, the bed slope is given as 0.01. So what we do is, let me explain you first. Let's say this is the river ridge, and let's say this is point A from where we want to start, and this is the point B, which is the end point. So let's give a station number. So let's say this is station number 1, and let's say this is 150, because I'm going to say that this distance is 150 kilometers. 150 kilometers. So just assume. Okay, so this is A is the name of A is 150 and B is 1. So the distance between these 2 points is 150 kilometer, and let's create some hypothetical data now. We have already assumed that the cross section uh, is going to be rectangular. So at this point the rectangular channel looks something like this, and let's assume that the RL of this point is 0, and we are given with this information that this information is 50 meters. So let's take it as 50, and height we can assume it to be, let's say 30 meters. We just have to make sure that water does not spills, so let's assume it to be 30. So I'm assuming this to be 30. Now the coordinates, we also need to supply the coordinates of these points wherever I'm marking. Let me put a new color here, so let's say maybe blue. So I need uh, the coordinates of this point. So the coordinate of this point is going to be, if I take just a reference axis in HECRAS, we have to put elevation versus station. The station is from distance from this reference axis. So our cross section is something like this. the downstream cross section, so something like this. So our the coordinates is going to be, the station is 0 comma, the elevation is, we have assumed to be 30. So this point will have the elevation coordinates as 30, 0, and this point will have, again, it's going to be 0 comma 0, it's an origin, and this point is going to have 0 comma 50. Sorry, yes, elevation is 0 and the station is 50, and again the elevation here is 30 comma 0. Likewise, we have to create the cross-sectional information. Since we are running a hypothetical channel, so we have to create a hypothetical data, the geometry data in HECRAS. Okay, likewise, now if point B is 150 kilometers away, what will be the elevation if the slope is, what did we assume? This is the channel that we are interested to simulate, so it is, slope is 0.01 and Manning's roughness 0.06. so if I multiply this 0.001 with the kilometers, it's 150 into 1000. This much would be the elevation difference. So how much it is? So let's quickly calculate this. So it's going to be 0.001 times 150 times 1000, 123, going to be 150. So 150 meter. So this point is 150. So what I do is, the coordinates is going to be, use a different color, purple this time. So here, this is the coordinate of this, the elevation of this is going to be 150. So if it is 150, so accordingly we have to make the coordinates, find the coordinates of these points, and we can also assume the same thing, height being 30. So here is going to be 0 comma 180, right? This is going to be 0 at the station, and elevation is going to be 180. So likewise, we have to create a geometry. So this is the fictitious geometry that I have just created based on this paper by Professor Perumal. With this, let's create our geometry. To do so, first we need to create a river ridge. So I'm creating this as a river ridge. So let's name this river as river 1. River 1, you can name it anything. So this is ridge. So one river can be broken down in many ridges, so I just want to name this as river 1 and ridge 1. Okay, so now next thing is to put the cross section that we have just made here. So to do this, we can go to the cross section panel here, new window comes up, and options, let's add a cross section. So here comes station, right? So station is, let's start with 150. So I have named this as 150, right? And usually the higher value would be considered, the HECRAS considers the higher value as the upstream, so 150. So this is just a name, okay, name of this cross section, so 150. Okay, next is station versus elevation. So we have to input the coordinates of the cross section. So let's quickly put this 0 comma 180, because height is 30 meter, is going to be 0 comma is going to be 150, because we have found that elevation of this bottom is 150. Again 50 comma 150, yes, and then again it's going to be 50 comma 180. So, and distance, the left of bank, right of bank, and the channel. If the channel is not straight like this, then the left side and the right side length is going to be different, right, in a curvature. So but now we assume the river was straight, so the distance is 150 kilometers. So 150, 1 2 3. So this is going to be control C, control V, control V. So we are assuming this to be a constant. and also we have assumed the Mannings to be 0.06. So let's assume this to be 0.06. So copying this value, Control C, Control V, Control V. So done. Almost everything is done. So, and also we have to supply the information which one is left bank and which one is right bank. So 0 is the left bank and 50 is the our right bank, right? So when I plot the data, you will understand better. So see, there is a rectangular channel, the bottom is 150, exactly like we have made here. So bottom is 150, 150, height is 180, height is 180, and Manning's roughness coefficient is 0.6. Done. That is all the information we need to put. That is at cross section A. Likewise, I'm going to copy this current cross section and I'm going to station at 1. So this is, I said this is going to be 1. When I say OK, everything gets copied. Now we have to make changes. The reach length means distance from this cross section to the next cross section. So here at B, we don't have any other cross section, so I'm simply going to put this as 0. So 0, 0, 0, because this is the last cross section. Everything else remains same. I have to change this. So this bottom is going to be 0, this bottom is going to be 0, this will become 30, and this is going to become 30, right? So this is going to be, we can cross check our information here. So this is what we have done: 0, 30, 0, 30, 0, 0, 0, 0, and 50. Station is 50, elevation is 0, this one, and station is 50 again, station is 50, and elevation is 0. So everything is fine. So reach length also 0, Manning's coefficient same, everything is same. So the reverse station is 1. So I'm simply applying the data. Oops, there is no information, doesn't matter. I can simply close this, and when I reopen, everything gets updated. So my cross section 50th, 150th is up here, my cross section 1 is here. So same thing we have obtained. If you want to cross check the cross section, we can do so. So this is my bottom cross section 0, 30, right? Everything is fine. And my next cross section is 150, 180. So everything is fine. Okay, with this much of information put, but with only 2 cross sections, the model won't run. So let's interpolate the cross sections at every 1000 meters. So what we can do is tool and then interpolate within a reach, right? Within a reach or 2 cross sections. So since both are valid in our case, so I'm just putting within a reach. So upstream is 150, downstream is 1. Everything is fine. And linear yes, and the maximum distance between two cross section is, let's put 1000. So 1000 becomes our, in every 1000 is going to interpolate a cross section and it's going to put. So let's interpolate. So close. So see, now it has interpolated. And if you see the cross section 150, next 149, 148, and it goes on. So see how the cross section is varying, right? So it has already interpolated it for us. Okay, with this much of this is the only information that we need to provide the geometric data. So with this, let's save the geometry data. So save geometry data within the HECRAS folder as geometry, or I can simply say channel, what was this, ch10, because we were running for channel section 10 of this example. Okay, done. So channel 10, our geometry is done, so I can just close it. And this is my main file. So here it has appeared now, geometry 10, and here is the location of that file. Okay, now next information is we need to put the unsteady flow information. So here we have to put the flow information. There is boundary condition, there is initial condition. So let's put initial condition. So initial condition means what was the flow there. So I'm just assuming it to be 100 cumex. And boundary condition, as you click on this channel, it will automatically highlight what is possible to put. So here I have more information here. These are the, I can either put stage or flow, or stage and flow, both I can put. So here I have already made the flow hydrograph, so I'm simply going to copy and paste the flow hydrograph here. So what I do is I click on flow hydrograph, a new things pops up. So I already have my flow data ready. I'm going to simply copy this and I'm going to put it here. Control V. Done. So let me also today, okay, no problem. Time, let's say 000000, no problem. Okay, so let me plot this data. So yes, this is my inflow hydrograph. I wanted to see what happens when I input this hydrograph in my channel reach. Done. That's it. Now the downstream, I have this many options, but now at the downstream side I have no information. So what I do is I put normal depth. It is in fact asking me the frictional slope. Since I don't have frictional slope, I will simply put the bed slope. So that's it. So I can save the unsteady flow data as save unsteady flow data as flow. That's it, because I'm running it for channel 10. So flow 10. So I can close this. Okay, everything is done. Now only thing I need to do is run this. The last and the final part is to run. So run unsteady flow analysis, and I want geometry processor, I want unsteady flow simulator, I want everything, and I have to put the computational interval. So computational interval by default is 1 minute. So let it be like that. So mapping output, I would like to have it at 5 minutes. So I'm going to put it at, where is it, 5 minutes. And hydrograph output, I want to have it at 5 minutes interval, and detail output also I want to have it at 5 minutes, because my inflow was 5 minutes. So 1 minute the program will automatically interpolate and then calculate at 1 minute interval. I also need to put the starting date. Starting date is, I have used today, and time was 0000, and ending date I am not sure. What I do is, again I go to edit, uh, unsteady flow data. So I just go and click and check the last date. Last date is 21st. Oops, I have also kept it as 1 hour. So I need to change this, because this inflow data is of 5 minutes. So 13:15. So it is this, how I put 15th November 2020 13:15. So this is how I need to put 15th November 13:15. Okay, just in case if I forget, I'll just leave it here. 15th November, that is today, 13:15. So this is it. So I can simply say run. The unsteady flow editor contains data that has not yet been applied. Oh yes, so because I made some changes, I did not save it, right? So it's saying it is not saved. So yes, run. So yes, finally it has finished unsteady flow simulator successfully. That's it. Now let's go and check the results, and we can check the result at every cross section. So let me see now what happened. This is at which cross section it is. Okay, nothing has appeared. Let me go and check on table. Okay, something has gone wrong, so let me quickly go and fix where it has gone wrong. Edit, unsteady flow data, everything is okay. 5 minutes, okay, file, save, done, and running unsteady flow data. So let me try to run this. Plan 1, everything is fine. Plan 1, everything is okay. Let me run it again. Close. Again, there is no value. where it has gone wrong. Let me fix this. Okay, so there is something fishy going on here. 13 15. Yeah, okay, 13 15. We have put the right information. That is 15th November 13:15. So it should be okay. So this was the file that we have put. There's a tabular value, flow date and flow information, no problem. Okay, it is not a problem. Boundary condition is there. So let me see the plant. So without changing much, maybe I forgot to put post processing here. Let me see. Okay, now it did some work. Close this and see. Oops, the post processing was missing. So this is how we do the analysis. But the model did not went well because there is some, you can see this deep right in the rating curve, which means the fluctuation was there. So this is not a very stable model, so we have to do something on fixing some errors. I mean, we can do the cross section that we have created at 1000. Maybe it was too large for computer to solve it. That's why it's creating some mess. But anyways, this is how we do the analysis. Now if you want to retrieve the information, this is how where we can retrieve the information at particular option profiles. So this only for maximum profile. So reach 1. Okay, this is where how we visualize things. Okay, this is it.